So don't ever think that somebody ever has the ability to decide what I will get or what I will not get. It is always me who gets what I want. Yeah? I mean, it might not hold true in case of, okay, I want a boba tea today and my dad says no. So it's not that, oh, I decided I want to have boba, so I'll get it. No, not that way. I'm saying what with respect to the longer term outcome, okay? Yeah? Let's say you want to become a basketball player. So you will become a basketball player only if you want to do it, if you put effort for that. Okay? Yeah? Alright. So that was more of a what do you call pep talk, and only outcome or only message from that is I have to take responsibility for whatever I am today and whatever I want to become tomorrow.
Okay.
Yeah?
Okay.
If you think, oh, it's because of my brother I'm getting less score in maths. No, it's because of you. If you study well, you'll get more. Okay? So always keep that in mind. It's about taking responsibility. So we will make our maths easier, better for ourselves because we want to do it, not because somebody else wants to do it. And nobody can do anything about my maths becoming better or becoming worse. Alright?
Yes, sir.
So we'll start with the basics again. And what are the basic tables? Let's revise. So I will make sure that in next 50 or before Thanksgiving, let's say, before Thanksgiving, you guys become a champion in tables up to 20. Okay?
Oh.
That's my target.
Okay.
12 9 there.
Well, 108.
Pretty close. Yeah, I mean, you're right. You took 1 second extra. I don't want that second to also go. Okay, 13 5 there. 65.
Yeah.
Okay. 14 4 there. Okay. Don't use pen paper. I want you to say it. Don't do any calculation. 15 9 there.
What?
15 9 there.
15.
135.
Okay. 135. So that 135, that pause is what I want to get rid of
Okay.
for you all. I'll say 12 9 108. Likewise. 11 7 77. 9 8 72. Likewise, it has to come that way. And that is where you will see it makes your math or your calculation ability much more faster, much more better, much more powerful. Okay? So let's do tables from 12 to 15 quickly. It will not take more than 5 minutes, right? Say it with me. 12 1 12,
12.
12 2 24, 12 3 6, 12 4
48,
8, 12 5 60, 12 6 72, 12 7 84, 12 8
96.
96, 12 9
108,
108, 12 10 120, 13 1 13, 13 2
26.
13 3
39.
13 4 42, 52. Again, we will repeat. Whenever we go wrong, we will repeat. 13 1 13, 13 2 26, 13 3 39,
13
4
4.
52,
52.
13 5
13 5 are
65, 13 6 you for entire 1 hour. That might be just too much. But what you can do is, see everything that I start talking, right? Initial 5 minutes or 10 minutes are, kind of has a lot of information in it. Just watch that. And if you find it more interesting, you can continue.
Okay.
You can keep switching, keep moving your video little forward and then watch. But make sure that you are revising it. Right. So now let's look at what all we learned yesterday. We learned about shapes, right? We looked at this, 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 we looked at this. What else we looked at? We also looked at other polygons, right? Like a pentagon or something.
Yeah.
What else?
Dot. Oh, you have to get that.
Dot is there, line is there, line segment.
Octagons.
We also looked at parallel lines, right?
Yeah.
We learned about it. Octagons also, let's put a hexagon here, okay? Alright. What else did we learn? We learned about how to find area of this guy, and also we learned about right angle triangle also, right?
Yeah.
We learned about how to find area for these guys, right?
Wait, so what's the formula for the formula for these shapes?
Yeah. So you don't have a formula for every shape. You have to know the formula of some of the basic shapes, and then let's look at this guy.
Isn't there like different formulas for every shape though?
Not necessarily. And see, again, that goes against the basic building block of math. Math is not about memorizing things. It's not like a social study where you have to remember the dates and year for what happened when. Okay. Math is more about concepts. So you will learn some of the things. This one we are going to learn today. Okay. Circle we'll learn today. We learn about square, rectangle, and right angle triangle. Right.
Yes, sir.
Rest of things we can actually join. So we learned about area and we learned about perimeter. Perimeter is very simple. If somebody says you, there are the 4 sides, tell me the perimeter. You will just add them together.
Okay.
Right? If this is a pentagon and you know all the 5 sides, you will just add them. That becomes your perimeter. So perimeter is nothing but a string or a wire needed to cover the boundary of that shape. Yeah? So a square perimeter is 4 times the length because all the sides are same.
Yes, sir.
Yep.
Later.
Train, just me, Bobby. I mean, it's okay. It's fine. Huh? I'm fine. I got it. So basically, a square is something where all the sides are same. So the perimeter is 4 times the side. If you're talking about the rectangle, it has length and width. The perimeter is this length plus this length.
Wait, so for square it's
4
sides.
4 into length.
4 into length.
Yeah. See, ultimately what we want to measure all the sides. Okay.
Yeah.
Since you know that all the sides are same, why you have to say side plus side plus side plus side?
Yeah.
So this is 4 times the side.
So for perimeter we only add, right?
For perimeter you just add the sides.
And for area you multiply.
For area it's not. See, if you're looking at this one, rectangle or square, you will say length into width. Okay.
Yeah.
Since in case of square, length and width are same, so you say length into length.
Yeah.
Yeah.
Okay.
For rectangle, you say length into width. So this is how it is. Now triangle, right angle triangle, we derived that okay. This is something that is more like which comes by dividing a rectangle into 2 parts.
Yes,
So this
yes.
becomes half into length into width. Okay. This is only for right angle triangle. Now we will try to see. There are certain things that we have to figure out here. Let's look at this. A pentagon. Okay. If the shape is like this, where you know that this is 90 degree, this is 90 degree. Okay. This is some angle. We don't know what angle is that. Okay. All right.
Yes, sir.
And you know that this side is equal to this side.
Yeah.
So, see, this is what is called family, right?
Yeah.
So your daddy was worried about you putting on the clothes, right? See, my family is worried about this. So this is the value of a family, right?
I guess.
Now, no, it's not. I guess there is no doubt about it.
Yeah.
Yeah. All right. So now I also feel warm. You guys okay?
Yeah, I'm good. All right.
So, what I was saying was, there are some of the shapes for which you can derive the area and perimeter. Okay. So let's go step by step. Okay. We'll talk about what all we want to do, what all we can derive. Okay. We only know for now that. Okay. So let's do a recap before we move on. Okay. So area means something, any shape that covers certain space. So this guy is taking this much space. Okay, this is my area.
Okay.
Or if this is a picture of my land, I know this is this big. Okay. Perimeter means, or if you're looking at this area, this is the area, this is the space that this guy is taking. If you're looking at area of the circle, this is the space that this guy is taking. Okay.
Yeah.
So area means something that the space that it takes on a two-dimensional surface. Okay. This is the area of this guy. This is the area of this guy. Yeah. Clear? If somebody says what is the area of this guy, this is the total area, right? How we will derive that, how we will calculate, we will figure it out. But this is the area, conceptually, right? Let's say, if somebody says, what is the area of my sleeper, how much area it takes, what I will do is, I will make this portion wet, I'll step on the floor and take it out, and will make a diagram there.
Yeah.
That is the area it will take. So I need at least that much space to stand on the surface.
Yeah.
Okay? So that's what the area is. Am I making sense?
Yeah.
Okay? Alright. So, how much area this guy takes? What I'll do is, I will put some glue here.
Yeah.
And put it here. And then remove. It makes a mark on the surface. That is the area it needs. So, if I have to keep this guy in whichever place, that much space should be there. Otherwise, we cannot keep it.
Okay.
Yeah?
Yes, sir.
Can we put a helicopter in this garage?
No.
Because that needs a bigger area.
Yeah.
That's how we understand it. Right? Yeah? Alright. So this is the area. Now the perimeter, when we say, perimeter is nothing but the boundary. Okay? Always imagine whichever shape you are trying to get the perimeter for. Meaning, if you have to cover that place, how big a wire or how big the wall you would need. Let's say, if this is a square shaped land or a yard or whatever it is, perimeter means how big, how long is a wire or a string you need to cover it all
Okay.
on the boundaries. Yeah?
Yeah.
So this one, this one, this one, this one. I'll just add the sides. If somebody says my yard is like this, I'll add this one, this one, this one, this one, this one. This is the perimeter for me. If somebody says circle, that is what the problem is. I don't know what to add, what to count. I can put a string. I can walk along the border and put a string and measure the length of the string. That will be my perimeter. But there is no formula that I have apart from using the string right now. So, do you guys have you eaten apple pie or any other pie?
Yeah.
Pumpkin pie, any pie? Do you remember the shape of it?
It was like so a circle,
Circle,
with like
right?
lines inside it.
Right. So imagine the pie which is not broken yet, not
Okay.
divided among people, not made into small pieces. This is how a pie looks like. Very similar to a circle, very much a circle actually, right? So that is why there is a very good relationship the circle has with a pie. And that pie is written like this.
Okay.
Okay? And the value of this pie, is 22 by 7.
Yeah.
Okay?
Yeah.
This pie is always needed when you are dealing with a circle.
Okay.
Okay? So this is the other formula that you'll have to remember. The first formula that we remembered was if you are talking about a rectangular circle, quadrilateral where the sides are perpendicular to each other, meaning a square or a circle or a rectangle, the formula is length into width for the area, right?
Okay.
Yeah, remember that? Length into width. So for square it becomes length into width, meaning length into length square, and for rectangle it becomes length into width.
Okay.
Right? So this is one formula that you have to remember. What is the area of a circle? Area of a circle is pi r square, where r is the radius. So let's spend some time understanding the circle today. Okay? What happened? Getting tired
No.
of a circle, of a pie? I don't know which pie you like. I like which one? The pecan pie.
Oh, pecan.
Pecan.
Mm-hmm.
Okay. So let's look at the shapes a little bit first. And this is what you'll have to. So if you're looking at a circle, sorry, let's start with the, okay, let's gradually increase. Let's first learn about the single line. This is a line. This is a line segment.
Yeah.
That's all we know. Yeah. Okay. Now let's look at the next thing where we're dealing with more than one line or line segment. What is that called? It is called an angle. Okay? This is called an angle. What is angle? Angle is a geometrical thing or geometrical entity where two lines cross each other. So this line is crossing this guy. Okay? So the angle is a property which defines at what is the relationship between the lines, meaning how they are cutting each other. Are they cutting like this? Are they cutting like this? Are they cutting like this? Whatever, right? How they are inclined to each other. That is what is denoted by the angle.
Yes, sir.
Okay? So that's why if it is cutting each other at 90 degrees, it's called these lines are perpendicular to each other.
Yes, sir.
You would have heard that word, right? Perpendicular.
Yeah.
Yeah. So the angle is nothing but the inclination at which two lines cut each other. Okay. So this is the inclination, right? Okay. If let's say the lines are cutting like this, this is the angle. This is, let's say, this line AB and this is CD. Okay. Here they are cutting here. See how far they are.
Yeah.
How close they are. What if the lines are cutting like this? They're very close. Yeah?
Yeah.
Very much like siblings. Yeah? Yeah?
Yeah.
Here they're like enemies. They don't want to stay close to each other.
Yeah.
Here they're like family, siblings. Yeah? So this is the angle. So you can, now let's look at how do we know about the angle. I mean, how do we read angles? Okay? So if you look at one line and the other line cuts here, okay? This is the point of intersection
Yeah.
where they are intersecting each other. Okay? So on this line, if this is a straight line, okay? Do you know what is the total angle here to here? 180?
180.
Yeah? 180. Any horizontal line, okay? If there is a horizontal line and that any line cuts here, okay? Around this point, this is the angle 180, this is 180. So the total angle along a line is always 180. Okay? Okay? So from here to here, this portion, this total angle is 180.
Yeah.
Okay? And I'm making this a little different. This one is also 180. So any horizontal line, if you talk about, so this is a horizontal line, okay? This is a new line that is
Yeah.
cutting this line here, right?
Yeah.
So along this line, the total angle made is 180. Likewise, if you think of this as the baseline, okay? This is your line, okay? Then this angle from here to here will also be 180.
Yeah.
Along any line, flat line, if any line is cutting, the total angle will be 180.
Uh-huh.
Now, so forget about these lines now. Just imagine this line that is not there. Okay? What are you seeing here actually? A circle.
Yeah.
Now do the calculation again. You had 180 degree here, 180 degree here. How much is that total? 360.
Yeah.
So, when you are talking about a circle, you are talking about an angle of total 360 degree.
Yes, sir.
Yeah?
Yeah.
Make sense?
Um,
You don't have to say yes if you don't think I'm making sense, okay? I can try to explain it again.
Okay.
So, see, here, if you divide this circle into two parts, you are seeing this one line, this is the center. Whenever you are talking about a circle, you are always talking about a center first.
Okay.
Because what you will do is, you will put, you would have used that instrument, right, for drawing circles?
Yeah.
So, one side, there is no pencil, right? There is only
Yeah.
one needle. That you get stuck here, and then you are rotating this guy. Right?
Yes, sir.
So, there is always a circle, and there is a length. This is called radius.
Okay.
Yeah? If you make the radius bigger, so if, let's say, I'm here, and this is how much I will say this much. And if I am rotating like this, right? I'm making a circle of this size. I'm stretching my legs like this. And then I'm rotating it. I'm making a bigger circle.
Yeah.
Right? So that length which is helping me make that circle big or small is the radius.
Right in the middle, yeah.
Yeah?
And what's the other thing called? I forgot.
This is the center. This is center. Center means center, right? I mean, this is the center of it. This is where the what do you call the focus point is.
Yeah.
From where you will start. You cannot imagine a circle without a center. Yeah? Because you put a circle at center and then you are rotating around that center
Yeah.
to make the circle. So this is center and this is your radius. Okay?
Yeah.
So if you imagine this, okay, let's look at the circle again. So if you're talking about a circle here, what you did, you took a string. Okay, let's imagine like this. This is you, this is your hand, okay? This is where you're holding a string, okay? And you have a stone here. Okay? What you're doing is you're rotating the stone
Yeah.
being tied to the to the
Okay.
string. Yeah.
Okay.
What is happening is you're actually making this circle. Same way, imagine the fan, the ceiling fan.
Yeah.
This is where it is the center, right? And then the fan is revolving around that.
Yeah.
Yeah. So this is the center of the fan, and this is the blades that you see, which is rotating.
Okay.
So if you lie under the fan and see the fan rotating, what you will see is a circle, big circle,
Yeah.
and it's rotating, basically, right? So this is the radius. This is the center. Clear?
Okay. Yeah. Clear.
And if you think, okay, this if you just stretch this radius, okay. Let's say this is your radius, okay. Just stretch this here. So basically, what you did, you divided this circle into two parts. Yeah. So this is half of the circle. This is half of the circle. This is 180 degree. This is 180 degree.
Yeah.
Yeah. Any horizontal line makes 180 degree angle actually, if you look at it that way. Okay. Alright. So this angle, how you can relate it with the circle? The circle makes a total angle of 360 degrees. And you know how.
Yeah, I know.
Clear? Now, I told you the circle looks like a pie.
Yeah.
And there is a very strong relationship between pi and the circle. So the area of a circle is pi into r square,
Okay.
meaning pi into r, where r is the radius.
Okay.
So for any circle, if you want to know, if you want to deal with, like when we were dealing with square, we said okay, all sides are same. I just need to know the length. So if I know the length, my area is length square.
Okay.
My perimeter is 4 times the length. So if you just know the length, you can deal with that square.
Yeah.
Likewise, for the rectangle, you know that okay, it's only length and width. If I know the length and width, I can derive the area, I can derive the perimeter, whatever, right? Same way for circle, this has a very strong affinity relationship bonding with pi. It looks like a pi, so it is close to pi.
Okay.
So the area of a circle is pi into r square.
Yeah.
Okay? And perimeter of a circle, meaning the size of the string to cover this whole circle will be 2 times pi into r. That's it.
For
So-
a circle.
For the circle.
Okay.
So see, basically, you're only dealing with 2 pi into and r, 3 things, okay? If we are talking about area, this 2 goes here, so it becomes pi r square. If you are talking about perimeter, it just remains here.
Oh.
So if you are talking about area, this 2 goes on the top of this guy, becomes a
Yeah.
power for r. Otherwise, it's 2 pi r.
2 pi r. Okay.
2 pi r. Yeah? So circle is like pi, looks like a pi. So it has
And
a
pi
top.
equals 3.14, right?
3.14, 22 by 7 is what the value is.
Yeah.
So you can remember 3.14, you can remember 22 by 7. Either way is fine.
Wait, 2 by what?
22 by 7.
Ah.
The value of this is 3.14. If you do the calculation, you find that this is 3.14 only. Okay? So this is the area. Now let's look at some more things about the triangles and the other shapes that we have talked about. So since we have looked at the angle, angle is nothing but the inclination at which two lines cut each other or cross each other. Right? So let's look at what are the angles we are dealing with. Is it cold? Okay? You cover your ear. Okay? Now, if you are looking at a triangle, what do you see? You see 3 sides and 3 angles.
Okay.
Don't you?
Yeah.
Yeah. If you are talking about a quadrilateral, meaning a square or a rectangle or a trapezium or a rhombus or a parallelogram. Okay? Meaning a quadrilateral, meaning which has 4 sides. Any shape or any geometrical shape has that many, has same number of sides and angles actually. If you look at it, if you look at triangle, you have 3 sides and 3 angles. If you look at quadrilaterals, 1, 2, 3, 4. 4 angles, 4 sides. Okay.
Okay.
So here also 1, 2, 3, 4. 4 angles, right?
Yeah.
So always remember any pentagon or any polygon which has more than 2 sides, right? Any shape which has more than 2 sides has equal number of angles also. So
Have
triangle
more than 2 sides?
have same number of angles also as the number of sides.
Have the same number of sides.
Yeah. So triangle 3 sides, 3 angles. Quadrilaterals 4 sides, 4 angles.
Okay.
Again, when we are talking about quadrilaterals, we talk about rectangle, we talk about squares, we talk about parallelograms, we talk about rhombus, we talk about trapezium, whatever. Everything has same number of angles and sides. Okay, so let me delete some of it. So let's keep only one here for your reference. Okay, so let's say square or rectangle. 4 sides, 4 angles. Okay. Talking about a pentagon. How many sides? 5.
Yeah.
How many angles? 5. Always there is equal number of sides and angles. Okay. If you are talking about a hexagon also, same thing happens. Okay. 1, 2, 3, 4, 5, 6. Okay. Now, do you know what is the sum of all the angles inside a shape?
For what?
Let's say for triangle.
3? Wait, 6.
No, so inside the angle, as inside the triangle, how many angles are there? 3? 3 angles are there, right?
Yeah.
What is the total value of the angles? If I add this angle plus this angle plus this angle, how much is that?
6.
No.
3?
No. 180.
Oh, 180.
How about this guy? This should be easy.
360.
Yeah. How about this guy? Okay. I gave you guys a formula. 2n minus 4 2n minus 4 into 90 degree. Meaning, now look at this, okay? N is the number of sides. Okay? So, triangle, you have 3 sides. So, 2 into 3 minus 4 into 90 degree. 2 minus 3, 2 into 3 is 6 minus 4, meaning 2. 2 into 90 degrees equals 180 degree.
Okay.
Yeah? This is matching with what I was saying.
Yeah.
So tomorrow somebody will say, okay, this angle is 60 degree, this is 70. What is the value of this guy?
This is 8.
So you know that total is 180. So
Yeah.
one is 60, one is 70. So this makes it 130. What is remaining is 50. So this guy is 50 degrees.
50.
No, I'm saying, how do you calculate that, right?
Okay.
First, you have to know what is the total value of the summation of all the angles. Okay. So you know that for a triangle, what is the total value of all the angles? This is 180.
Yeah.
And that is based on this formula, 2n minus 4 into 90. So you know that the total sum of all the angles of a triangle is 180.
Yeah.
Okay. So if you know two angles, what is the third one? You just add these two and subtract from 180.
Okay.
Yeah.
That's it.
If I tell you only this one, if I say that one angle is 60 degrees, tell me what is the value of the two angles. There is no way you can find it actually. Yeah, because you know total. It's like A plus B plus C equal to 180, right? If this is one angle, this is second angle, this is third angle. Okay. You know A plus B plus C is 180, and I'm just telling you 60. So I'm saying A plus B plus 60 is 180. How would you know what is value of these two? You cannot find it out. You
Yeah.
need one more relationship. Okay, one more clue before you can derive this. Okay. So now second thing. So we found out what is the sum of all the angles for a triangle, right?
Yeah.
180. Using this formula. Remember this formula. Okay. 2n minus 4 into 90. 2n minus 4 into 90. This is going to remain a formula for you to know what is the sum of all the angles for any polygon. Now if you're talking about, let's say, I said 360 degree and you believed me, okay? But there was no proof. There was no way to validate it. Again, we'll use the same formula. This formula tells me why it is 360. So 2n minus 4 into 90. Here the value of n is what? For n is the number of sides.
Yeah.
So I'm talking about a rectangle or a square. It has 4 sides. So 2 into 4 minus 4 into 90. 2 into 4 is 8, minus 4 is 4. So 8 minus 4
4.
into 90
Yeah.
equal to 4 into 90 is 360 degree.
Okay.
So now you know how you can trust me. I said sum of all the angles of a rectangle or any quadrilateral is 360 degrees.
Yeah.
This is the way to verify that.
Okay.
Now whether it's a rhombus or a square or rectangle doesn't matter. Okay. If it's a rhombus, that means these angles are bigger, these are smaller. But again, adding them together, it has to be 360 degree.
Okay. Yeah.
So tomorrow if somebody asks you, find out the sum of all the angles of a pentagon, you know how to do it.
Yeah.
You'll use this formula. Put n equal to 5 and then you will know what is the total angle.
Okay.
Okay? Another thing that you need to remember is if the sides are same, the angles will be same.
It's size the same. Okay.
Yeah? So let's say I will close this one so that it's not very cold for you guys. I hope you get a And you have just light, right? You can still see, right?
Yeah.
It's better? Okay. Now if you want, you can move forward. That's okay. I'll put out some heaters now to make it warm for you guys. Okay. So. Okay. So what are the things that we have learned today so far? We learned about a circle. Circle is very much like a pie. Right? So all the things with little circle that we'll do will be related to pi. So area and circle is, I'm just dealing with a number, with a pi and a radius. These are the things that I need for a circle.
Yeah, okay.
So if I'm talking about a perimeter, that is 2 pi r. 2 into pi into r. If I'm talking about an area, this is perimeter. Okay. And if I'm talking about area, the same two jumps from here goes here.
Okay.
So circle is easy, okay?
Yeah.
Now whenever somebody says, okay, find the area of a circle, you know it's pi r square. Okay? If you're talking about perimeter, you're talking about 2 pi r. And pi's value is 22 by 7 or 3.14, whatever you remember. Yeah?
Yeah.
So pi is equals to 22 by 7, which is 3.14. Okay? Whichever you remember, you can use that. Okay? And r is the radius. So we learned about the circle, area and perimeter. We had learned about the perimeter and area of a rectangle and a square and also right angle triangle yesterday. Now, I told you that if the sides are same, the angles will be the same. Let's look at this. Let's look at this table. This triangle. Okay? And this is just to observe, nothing to memorize. Okay? Look at this side and the angle opposite to that. Look at this side and the angle opposite to that. This one. Okay? Look at this side and the angle opposite to this. Just based on your observation, which one looks the smallest of all the three angles? Which angle looks the smallest? If I say A and this say B and C, which angle?
C.
C looks smallest, right? If you just observe this triangle a little closely, which side looks the smallest of three? Which side looks smallest?
A.
A meaning?
Or B.
This is the side. This is called AB.
A to B.
A to B, right? This looks smallest, right? Just based on observation. There is no math here. Okay? So that is what you have to remember always. This observation is very right. That if the side is bigger in any polygon, the corresponding angle opposite to that is also big. Okay? So, if you are looking at, let's say, this one, okay? You will see this angle and this angle are big. Let's not look at this example. This will just get you confused. So let's look at another triangle only for now. Okay. What I'm telling you is this is 5 centimeter, this is 5 centimeter, and this is 3 centimeter.
Yeah.
Okay. I'm not sure if I've drawn this triangle correctly, but what I'm saying is these two sides are same. These two sides are same, and this is smaller. What you will find is this angle which is opposite to this side and the angle opposite to this side. If the sides are same, the angle will be the same.
Okay.
Okay? If the side is big, the value of the angle is big, which is opposite to that side. If the sides are same,
What if all the sides are not like the same length?
if they are not the same, the angles will not be the same.
Oh yeah.
Okay? That's very simple.
Yeah.
Okay? So, that is why now try relating this with a triangle which is called equilateral triangle. 6 centimeter, 6 centimeter and 6 centimeter. This is a triangle and this is called equilateral triangle,
Okay.
where all the sides are of same length. If the sides are of the same length, then the angles will also be the same.
Okay.
Are you with me?
Yeah.
Yeah? If the sides are of same length, the angles will also be the same.
Okay.
Because the angles always have a relation with the side, the opposite side. Okay? For any polygon. Okay? That means this angle, this angle, this angle and this angle all are going to be same for equilateral triangle. Can you tell me what is the value of each angle here?
What operation?
Now think about it. I'll make you guys think. Math is about thinking. First of all, do you guys know what is the total value of all the angles for the triangle?
Yeah.
How much is that? If I sum up all the angles,
18.
no.
Wait, 30.
We just learned it 10 minutes ago. We use this formula 2n minus 4 into 90 degree, where n is the number of sides. So if I'm talking about triangle 3 minus 4 into 90 degree, this equals 2. 2 into 3 is 6, minus 4 is 2 into 90 degree equals 180 degree.
Okay.
So that's what we saw 5 minutes ago. That if you add all the 3 angles of a triangle, it is going to be 180 degree. No matter what type of triangle you are dealing with, whether it's an equilateral triangle or an isosceles triangle or no.
Scaling.
What is that?
Scaling.
Say it loud.
Scaling.
Scaling.
Where no sides are equal.
Scaling. Is that what it's called? Okay.
Scaling is also used for volume.
Yeah. So regardless of whether the sides are of same length, non-same length, whatever, sum of all the 3 angles is going to be 180 always for a triangle. Based on this formula. This formula will never ever change. No matter whether you guys graduate, become doctors, do PhD, become scientists, whatever, this formula will not change. Okay? Where n remains the number of sides and depicts the number of sides. Okay? So 180 is the total sum of 3 angles. Now come back here. We were talking about an equilateral triangle which has 3 sides and all the sides are same. If the sides are same, angles will be the same. Meaning 3 same things if we add becomes 180.
Yeah.
Meaning 3 things which is same. If I don't know what is that, I will call it x. 3 times of an x is 180 degree. What is the value of that angle? 3 times something is 180. 60 degrees. So that means for an equilateral triangle, each angle is 60 degrees. And I am not asking you guys to memorize that. I am telling you guys how. Because you know that sum of all the angles is based on this formula. Be it for a triangle, be it for a quadrilateral, be it for any kind of polygon. You just put the number of sides and it will tell you what is the total sum of all the angles.
Yes.
So using that formula, you know that if you add all the 3 angles of a triangle, that adds up to 180 degree. And since it is equilateral triangle, meaning all the sides are same, that means all the angles are also the same. So that means three same things, x plus x plus x, 3x equals to 180. So what is the value of 1x? Yeah, you're dividing 180 by 3.
Yeah.
That's what is 60. Okay? Clear? So, if somebody tells you, this is the equilateral triangle which has all the sides 8 centimeters. Tell me what is the value of one angle. If it's an equilateral triangle, it will always be 60 degrees, no matter what is the size of the no matter what is the length of the side. Yeah?
Yeah.
Think about it. Now, so we learned about triangles, we learned about how to derive the angles, we learned about the area and perimeter of square, rectangle, circle. I want you both and also to Sid to go to Khan Academy and do these sums. No matter whether it's for 5th grade, 8th grade, 10th grade, 12th grade, doesn't matter. Because you will not remember maths as something which is related to a grade. You will remember math or learn math as a concept. Okay? Regardless of whether you're learning that in kindergarten or you're learning that in 12th grade. It's a concept. Okay? So I want you guys to do that math for area and perimeter for all the 3-4 shapes that we learned. Okay? Be it triangle, be it rectangle, square, and circle, and right angle triangles. Now there will be some derived shapes. Okay? Now you know what is area and what is perimeter, right? Conceptually, I'm not asking you as a formula. Okay? You know, if somebody says find out the area of a hexagon. Okay? You don't know the formula. Okay? This is a hexagon which has 6 sides. Area means how much space it will cover.
Yeah.
Okay? Perimeter means what is the value of adding all the sides. That will not change. How part is what you will need to figure out. Now, if somebody gives you this shape, okay, and asks to find the perimeter, you will add this side, this side, this side, this side, this side. Done. That is the perimeter. If somebody gives you this shape, gives you the side, all these sides, right? You have got all these sides, and says, get me the area. What you will do? You will have to break this into small pieces. Find out this area. What is the, if you know the formula, calculate this area. This is second area. Calculate the area of this part also. Add them together, that is the area.
Yeah,
okay. So you would not know the formula for each and every shape that you come across. There will be derived area for the shapes. I mean, by breaking that into smaller pieces also.
Yeah.
Alright. So that is this thing. Now, one thing you have to remember is, we learned what? This one. This is a right angle triangle. The area of right angle triangle is half into length into width.
Yeah.
Meaning half of the area of a rectangle that it would have made, because it comes by breaking into 2 parts. Yeah. Now, area of a triangle I'll teach you in the next class. Okay. I'll just tell you the formula. Okay. But whatever we have learned so far, I want you guys to practice and find out some sums on Khan Academy, online, whatever it is. And I want to see at least 10 sums or 15 sums being done and show it to me, saying that, okay, these are the 5 questions I found on area of circle or perimeter. I have done that. Just show me that, how you are doing it. And when you are doing it on a piece of paper, the way your brain processes that is how we write it, right? So show me the process actually. I want to see that because no, when you do it and show it to me, trust me, any doubt that you have in your mind, that will be cleared off.
Okay.
Okay?
Yes, sir.
So show me at least 10 to 15 sums in the next class. I want to see that. Trust me, if you just sit with full focus for 15-20 minutes, you'll be able to do it.
Yes, sir.
I'm not giving you guys a bigger assignment. Okay?
Okay.
Do some sums where you're deriving the area of rectangles, squares, circles, and show me 10 sums. Same thing applies for you also, Myra. I'm not going to remind you every day of the weekday, but I want to see it on next Saturday. Okay? Same thing for you, Google.
Oh, okay.
So show me 10 sums because I want you guys to practice maths. I don't want you guys to memorize math. Math is not about memorizing it. Okay? It's about practicing. Okay? Alright. So that's what brings us to the end of this class. Any questions that you guys have?
No, sir.
That is not good. You need to have questions. If you don't ask questions, what will I teach? No. So, what I'm trying to say is just feel comfortable, ask questions. Whenever you have doubt,